Right, okay, we're going to attempt this physics paper light, so wish me luck. Oh my god, what a question. Student is investigating refraction, maths mode. What is refraction? Refraction is so this is how they've worded it, the change in direction of waves, right? Not, it doesn't have to be light waves, at a boundary. So normally when you go from a low medium, dense medium to a high dense medium, low density medium to a high density medium, it'll change direction. And I always get it wrong which way around, but we will discover that. So should we write that down, refraction? I think that's going to be a useful one now. Refraction is the change in direction. Yeah, okay. Change in direction, and this is because there's a change in speed, change in direction of waves at a boundary. Let's carry on. Where are we? The diagram shows a ray of light traveling from air to glass. Add labels to show the angle of incidence and the angle of refraction. Okay, so first of all, look, this line that is perpendicular at right angles to the boundary is called the normal. This ray coming in is the incident ray. This ray that's being bent is the refracted ray. You always measure the angle to the normal, so it's this angle we're interested in. So this is the angle of incidence, and this here is the, oh, I fell for it. This, let me just change color, might be useful now. This here is the angle of refraction. Angle refraction. This is the angle incidence. Right, okay, that I think is a good one to get hold of. So I'll tell you what I'm going to do is I'm going to cheat. I'm going to cheat. I shouldn't cheat, but so what I'm going to do is I'm going to put that there. That's part of our learning. So that's number one, and this is the diagram 2. Let's carry on. Right, the student wants to find the refractive index. State the equation linking refractive index, angle of incidence, and angle of refraction. Right, okay. I think we've done this in another video, but this might be slightly better for us. So we can say refractive. Remember, you're going to have this anywhere, but like I said, if you want to do well, it's best to have this in your head or be familiar with any angle of incidence divide the sine of the angle of refraction. So let's do the same thing here. Right, it's good to know that refractive index n. So let me just put that down. Refractive index n equals, so let me just take another copy of that. Right, okay, there you go. Right, this is, we haven't done this in the other videos, but this is the one that I was looking for. It's an experimental detail. So we've got the ray box. We'll have a single ray coming out of there. You put a light in here. You put your glass block here, and you get your protractor to measure the angle of refraction and angle of incidence. Right, so we need to describe a method on how to work out the refractive index. Just one second. So the refractive index is how much the refractive index is how much a light is bent, or how we defined it up here was the right, okay, so what we want to do is, let's put it here in words. Refractive index is how much material bends light or refracts light. Bends light. That's it. That's a good one to just have in the back of your mind. If you want the higher marks, then suppose it's right. We've got 6 marks. How do we carry the expression? Right. First of all, draw around the block, on the block of glass. You shine the ray of light on the block and mark it. You also mark the refracted ray okay, so now what you do is you measure the incident ray and refracted ray. Measure the incident ray and the refracted ray. Measure the incident ray and the refracted ray. Draw around the block. Yeah, okay. On the paper. So let me explain that to you. So here's my block. That there is the paper. So I draw around the block. I shine a light. It's going to get refracted, and it's going to do that. So then what I do is, there's the normal, there's the normal. I'm going to mark this point and this point and draw a line. I'm going to mark this point and this point. I'm going to remove the block. So if I delete that, I'll see what it'll look like. So just stay with me. I've removed the block. Now what I do is I draw a line from there. Oh my god, did I just do that? Oh my god. What's going on? So what I'm gonna do is I'm gonna draw a line. Let me get a blue line. Draw a line. Right. I've got my normal. Then I will go ahead and measure this angle, and I will measure this angle, I and R, angle of incidence and angle of refraction. I'll put it into a table. So I and R, just say for example that's 30 degrees and I don't know, that's 25 degrees. Then what I do is change the angle of incidence and also measure the angle of refraction. Do the above steps for a range of values. Right, then we can repeat to make sure are correct. Right, then what you do is you plot a graph of sine I over sine R, and you'll get a gradient. Bear with me 1 second. Okay, yeah, we'll just leave it at that. That's what you plot, and then 9, work out the gradient, to give the refractive index. Right, that's it. So if you can just figure this one out, yeah. Draw around the block, shine a ray of light on the block, mark it, mark the refracted ray, remove the block and measure the incident and refracted ray angle. Change the angle of incidence, do the same again, repeat for a range of values. So what happens is you'll get a range of values that we can draw a line through, and from that you repeat it, remove any anomalies, and you can average out for the same angle. You plot a graph of sine I over sine R. So you've got to just write this in. You plot that graph and then you end up with a gradient. Just say something like this. And then you work out the gradient. That will give you the refractive index n. That's it. Just keep repeating that and it'll go into your brain. Right, we're going to call it quits there. I think that's a good one for the first one then.